As well as our orthopedic imaging system, we are developing a system for imaging chests. So lung imaging is the most common type of X-ray imaging at the moment because it's a key indicator for so many different diseases and conditions. So to do that, instead of just having one flat panel source, like we have in the top here, we can combine multiple flat panel sources together to cover a larger area. In the same way that at a big sports event, the big screen is actually made up of 9 smaller synchronized screens working together. So that means we can do something transformational, which is bringing 3D imaging to the bedside. Previously, that was only possible if you transport the patient to a CT scanner or an MRI scanner. Much, much more expensive and complicated to do that. This is a 2D image of 2 big thick racks of ribs and some lungs in between with a nasogastric tube that has been inserted into the lungs. These are the feeding tubes that you see in the hospitals. Occasionally they might go down the wrong tube and into the lungs, and it's critically important to detect something like that. With a 2D image, quite difficult to see that because all the ribs and the tube and the lungs are superimposed in 2D. Whereas with our imaging, we can go through each layer of the chest at a time. Here we can see the lower set of ribs. As we go slightly higher up, we see a clear view of the end of the tube and starting to see the bronchioles in the lungs. We go slightly higher up, we see the branching of the airways, the next layer of the tube, and then we come up to the top, we can see the top layer of the rack of ribs. So this is really exciting because for the first time we'll have low-cost, low-dose 3D imaging available at the patient's bedside.